object is simply a piece of another solar system.
This thing came from interstellar space into our solar system, and the main question is, what could it be?
The small cosmos of our own Earth buzzes with intrigue as stories swirl around Oumuamua, a celestial voyager from the vast reaches of space, rumored to be an indicator of danger on its return. This weird object burst onto the scene in 2017 as the first confirmed visitor from beyond our star system.
This was not some solar system object falling from a long way away. This was something that came from another star, and I think everybody was pretty amazed by that.
Oumuamua threatens our world and behaves against cosmic laws with an unexpected comeback. What mysteries does it hold from the universe unknown? Join us on an adventure to discover the wonders of these celestial wanderers and experience the inspiring mysteries of the universe. A creepy alien scout or a cosmic drifter? It's important to set the record straight and mention that the stories going around about Oumuamua coming back to Earth and being a danger to us are more than possible. In reality, Oumuamua is a very intriguing visitor from outer space that just passed by once, minding its own business, as it traveled through our solar system and then continued its journey, heading out into the vast universe. Scientists all over the globe have been keeping a close eye on it, studying every detail they can. And yes, Oumuamua has definitely sparked a lot of interesting conversations and curiosity about objects that come from beyond our own solar system. But all the studies and observations have only led to the conclusion that Oumuamua is a natural object floating through space, just like countless others in the cosmos. Back in 2017, there was a big moment for space enthusiasts and scientists alike. Imagine the excitement when researchers announced they had spotted Oumuamua. This was no ordinary piece of space debris. Oumuamua was hailed as the first ever detected visitor from a different star system, a true interstellar traveler passing through our solar system. This was a groundbreaking discovery because, before Oumuamua, we had never seen anything from beyond our solar system up close. Its appearance was a big deal because it opened up a whole new chapter in space exploration, offering us a tangible glimpse of the materials and objects that exist in other parts of the galaxy. Oumuamua's journey through our solar neighborhood was a unique event that captured the imagination of people around the world. Scientists eagerly collected as much data as they could while it was within reach. This interstellar object became a subject of intense study because it offered an unprecedented opportunity to learn more about the universe beyond our solar system's borders. The excitement around Oumuamua wasn't just about where it came from, but also about what it could tell us about the cosmos. It raised many questions and made us wonder about the origins and nature of such objects. Could there be more out there? What could they tell us about the universe and the possibility of other star systems with planets like ours? Although Oumuamua's visit sparked many wild theories and speculative stories, the core takeaway from its discovery is rooted in scientific curiosity and the pursuit of knowledge about our universe. It's a reminder of the vast, unexplored spaces beyond our own planet and the continuous quest for understanding the mysteries of the cosmos. We are talking about a massive, rock-like object, shaped somewhat like a cigar, larger than any football field, gracefully spinning through the vastness of space.
Almost sort of shaped like a cigar. It's 10 times longer than it is wide.
And this is extraordinary. There's no object in our solar system that we've ever measured that is this elongated.
Its exterior boasts a deep, reddish hue, a testament to countless years under the influence of space's cosmic rays. In Hawaiian, this object is known as Oumuamua, which translates to scout. This name is quite appropriate given its role as a mere visitor to our solar system, seemingly on a brief tour of observation. The existence of Oumuamua left many scientists puzzled. The reason for their intrigue was its unique shape, which was distinctly different from the familiar forms of asteroids and comets that we know, which are typically more spherical. Oumuamua, on the other hand, was elongated and slender, resembling a space-traveling cigar. Its trajectory through space further compounded the mystery. Unlike the usual paths taken by space objects, influenced predictably by the sun's gravitational pull, Oumuamua's journey was anything but ordinary. It accelerated and veered off course in ways that puzzled observers, leaving them to wonder about the forces at play. Several theories emerged to explain its peculiar movements. Some scientists speculated that the object could release gas, much like a comet, providing the thrust needed to alter its course. There were even more outlandish theories suggesting the possibility of alien technology being involved. However, the window for study was painfully short. Oumuamua was traveling at such a high speed, and its detection came too late for a detailed examination. It swiftly flew by Earth, made its closest approach to the sun, and then it was gone, exiting our solar system as quickly as it had arrived. As Oumuamua continues its voyage across the cosmos, it symbolizes the aspirations and curiosity of humankind. It reminds us of the vast unknowns lying in wait for us to discover them. Perhaps in the future, we might encounter Oumuamua again, or something similar. Next time, we might be better prepared to uncover the secrets it holds. We're about to dive deeper into space exploration, focusing on space probes and our quest to uncover the secrets of the universe, the architects of infinity. Imagine space probes as robotic explorers we dispatch on grand adventures into the cosmos. These are not ordinary robots. They are equipped with highly advanced scientific instruments. These instruments are like the robot's eyes and ears, allowing it to see the wonders of space and hear its secrets. They capture this information and send it back to us on Earth using radio waves. This process allows us to learn about far-off planets, stars, and even the vast emptiness of space, places we can only see in our dreams or through the lens of a telescope. Since the mid-20th century, specifically from the 1950s onwards, humans have sent these robotic explorers into space. With each mission, these space probes help peel back another layer of the universe's mysteries. It's fascinating to think about whether there are other civilizations out there doing the same thing. Imagine, for example, if beings from a galaxy like Andromeda, which is an astonishing 2.5 million light-years away from us, decided they wanted to explore Earth. Considering the vast distances involved, a probe from Andromeda traveling at the speed of light, a speed that is the absolute limit according to our current understanding of physics, would still take millions of years to reach us. These hypothetical beings would need technology beyond our current imagination to undertake such a journey, perhaps involving concepts like wormholes or warp drives. These ideas, which come straight out of science fiction, propose ways of bending the fabric of space and time to achieve faster-than-light travel. While these concepts are purely speculative and not grounded in our current technological capabilities, they spark the imagination of scientists, engineers, and anyone fascinated by the possibilities of what lies beyond our solar system. However, the challenges of interstellar travel are not limited to just speed. Space is a hostile environment, filled with radiation and debris that could easily damage or destroy a probe. To safeguard these probes on their long journeys, we would need to develop materials that are incredibly resilient and can withstand the harsh conditions of space. Researchers are constantly at work, trying to invent new materials and technologies that will allow space probes to survive and continue sending back valuable information from the far reaches of space. Looking to the future, our goal is to create space probes that can travel even farther and survive longer in space, unlocking more secrets of the universe for us. Perhaps one day, we might even receive a probe from another civilization, a sign that we are not alone in this vast universe. Until that day comes, we will continue to send our probes into the unknown, each one carrying our curiosity and the collective hopes and dreams of humanity as it ventures beyond our solar system. In 2017, the discovery of Oumuamua caught everyone's attention because it was the first object from another star system observed passing through our own. Its odd speed increase and unique shape sparked a lot of guesses about what it is, including the idea that it might not come from natural origins. Avi Loeb, an astronomer at Harvard, raised the possibility that Oumuamua could actually be a spaceship from another world.
It reminded me of some designs we had for interstellar spacecrafts that have to be much longer than they're wide in order to minimize friction with the interstellar gas.
Pointing to its strange speed boost and form as evidence. Yet, in his latest research done with Thiem Hoang, Loeb critiques a previous study by Jennifer Bergner and Daryl Seligman. He argues that their theory, which suggested Oumuamua was a comet with some water ice, failed to consider how the evaporation of hydrogen could cool it down, leading them to overestimate how hot its surface could be. Adding to the enigma, newer studies have brought up the idea that Oumuamua might be a piece broken off from a planet similar to Pluto, but located in a different solar system, shaking up earlier thoughts that it was comet-like. This angle hints that Oumuamua and objects like it could give us a never-before-seen peek into the makeup of other solar systems. The concept of panspermia, which suggests life could spread through space on objects like Oumuamua, has also captured imaginations. Although recent findings suggest it's very unlikely that panspermia brought life to Earth, it still highlights the intriguing possibility of life traveling between planets that can support life in our galaxy. NASA found that as Oumuamua journeyed through our solar system, it sped up unexpectedly, similar to how comets move when they let out jets of gas. This behavior matches what we know about comets, but doesn't completely cover all the odd features of Oumuamua. The ongoing discussions and research into what Oumuamua really is underline the cross-disciplinary nature of studying life beyond Earth and the endless pursuit to unravel the universe's complex secrets. Each theory and discovery pulls back a bit more of the curtain on the deep mysteries lying outside our solar system, showcasing the lively and changing realm of space research and discovery. As it neared our sun, the comet started losing material, including dust and water, showing activity from late 2018 to mid-2019, while it was within 4 to 5 times the distance from the Earth to the Sun. It came towards us from the direction of the constellation Cassiopeia, hinting at its origin in the flat disk of our galaxy, and will exit our solar system, heading towards the constellation Telescopium. Observations suggest it spins slowly, taking more than 10 hours to complete a rotation, with models pointing to a tilt of around 59 degrees or even 90 degrees, with the latter being more likely based on its current path. Now we'll explore the story of Oumuamua and 2I/Borisov, two objects from outside our solar system that challenge what we know about space. The strange pattern of Oumuamua and Borisov. Oumuamua, a visitor from beyond our stars, caught the attention of the scientific community with its unusually long and narrow form and its behavior, which didn't match that of typical comets or asteroids we're familiar with in our solar system. Its peculiar movement and sudden increases in speed sparked conversations and theories about what it truly is, marking it as an outlier among cosmic objects. On the other hand, 2I/Borisov, another interstellar visitor, demonstrated clear signs of being a comet by releasing gas. But with a twist, its gas had more carbon monoxide than any other comet observed at a similar distance from the Sun. This unique composition made scientists rethink their theories on how comets are formed and hinted at 2I/Borisov being an exceptionally unaltered example of a comet, providing a direct insight into the materials from which it originated. Oumuamua emerged from the depths of space, making its way into our solar system as if it were a wanderer between the stars. This celestial traveler, without a permanent place in the cosmos, exhibited varying levels of brightness, a phenomenon that helped astronomers deduce its physical characteristics. Its appearance changed depending on the viewpoint. appearing more luminous when its broader side was visible. Such fluctuations in brightness were key observations for researchers like Meech, leading to the conclusion that Oumuamua's shape was unusually elongated and tapered, resembling a giant cosmic cigar. This shape, coupled with a rough, uneven surface, added to its mystery. Sporting a reddish hue akin to distant objects in our solar system, Oumuamua's coloration and lack of surrounding dust indicate its composition is likely solid, possibly comprising rock or metal elements. The absence of water or ice on its surface and its reddish appearance may result from prolonged exposure to cosmic rays, energetic particles from space that it endured over countless millennia. Traversing the Milky Way for potentially hundreds of millions of years in solitude, Oumuamua's origins remained elusive until scientists traced its journey back to a close encounter with several stars around 1 million years ago. Its nearest approach was to a dim star named HIP 3757, suggesting its voyage might have begun in that vicinity, or that it has been adrift in space for an immense duration. Unlike the familiar, predictable paths of celestial bodies within our solar system, Oumuamua's trajectory was highly unusual. It approached us at an extraordinary velocity, making it clear that it was not gravitationally bound to the Sun. Originating from the direction of Vega, its speed and trajectory were distinct from the orbital paths of planets and other solar system bodies, highlighting its interstellar nature. By mid-November, after continuous observation over 80 days, astronomers confirmed that Oumuamua's characteristics and path firmly distinguished it from typical comets or asteroids originating within our solar system. Its highly elongated orbit was unlike anything previously observed, underscoring its status as a transient visitor destined to return to the vastness of space. Its movement, not influenced by the gravitational pull of any known planetary body, underscored Oumuamua's unique nature and continued to pique curiosity. This object, unlike any seen before, serves as a poignant reminder of the endless mysteries and the expansive unknowns of the universe. In 2017, the discovery of Oumuamua, a mysterious object from space, sparked widespread interest among scientists around the world. The reason for this excitement was its unique trajectory through our solar system, which was unlike anything observed before. Oumuamua was not just another space rock like the comets or asteroids that are part of our solar system family. It was moving along a path that was significantly more elongated than the paths of any other known space objects. This path, which scientists refer to when they talk about an object's eccentricity, had a value of 1.20 for Oumuamua. This meant that its route was so different that it wasn't just visiting. It was on a one-way trip through space, coming from and heading back into the unknown depths of our universe. When scientists talk about eccentricity, they're discussing how to describe the shape of the path that a space object takes as it moves around the Sun. Most of the time, the objects we see in our solar system travel in paths that look like circles or slightly squashed versions of circles, which we call ovals. But Oumuamua's path was much more stretched out than that. It didn't circle back around the Sun in the way that planets and asteroids, which are part of our solar system's regular traffic, do. Its trajectory indicated that it was just making a brief visit, coming from somewhere far beyond our solar system's boundaries. The suddenness of Oumuamua's discovery prompted astronomers from all over the world to scramble in an effort to observe this fleeting visitor before it could escape too far from view. With its very large telescope, the European Southern Observatory in Chile became a focal point for these efforts. A group of scientists, led by Karen Meech, utilized a sophisticated camera to study Oumuamua in various types of light. This allowed them to gather data on its surface properties and how it reflects sunlight. They noticed that Oumuamua's brightness varied significantly by up to 10-fold as it rotated every 7.3 hours. This variability in brightness offered yet another hint that Oumuamua was no ordinary comet or asteroid from our solar system. It suggested that Oumuamua might have a more elongated shape or a more varied surface than familiar space objects, leading to unusual patterns in how sunlight reflected off it. As we learn more about Oumuamua, we discover a universe full of mysteries, urging us to find out more about these interstellar visitors, a peek into interstellar secrets. The finding of Oumuamua has sparked a new wave of excitement and curiosity among those who study the stars and the cosmos. Before this remarkable discovery, our knowledge was limited to objects born within the confines of our own solar system. The unexpected visitor, Oumuamua, hinted at the thrilling possibility that our cosmic neighborhood might be a regular path for numerous other objects from distant parts of the universe. This opens the door to a wealth of information about regions of space that are far away from us, offering glimpses into the vast expanse beyond our solar system's borders. Researchers are now more motivated than ever to delve into the mysteries of Oumuamua and to keep their eyes peeled for other similar cosmic wanderers, with the hope of unraveling more about the mysteries that lie in the space that surrounds us. Oumuamua is an extraordinary celestial object, different from any other we have encountered. Imagine a cosmic entity shaped much like a long, slender cigar, dashing through the vacuum of space. This description fits Oumuamua perfectly. Its dimensions are peculiar, much longer in length compared to its width, a characteristic not typical of the comets or asteroids commonly observed. This unusual traveler caught the gaze of the global scientific community and many powerful telescopes as it made its swift passage by our planet. Picture this object hurtling through the cosmos at an incredible speed of approximately 85,700 miles per hour, swiftly moving away from the warmth of the sun. Its journey through our solar system was unique, entering at an angle that saw it soar over Mars, cruise past Jupiter by May 2018, and slip beyond Saturn by January 2019. Presently, it is on a trajectory towards a sector of the cosmos known as the constellation Pegasus, taking it further away from the solar system we call home. Observatories around the globe, including the renowned Hubble Space Telescope, monitored Oumuamua for an extended period. This meticulous observation allowed astronomers to study it in greater detail, even though it appeared as no more than a speck against the immense pitch-black canvas of the universe. They discovered its origin point to be in the direction of Vega, a luminous star within the constellation Lyra. However, a fascinating fact emerged. Vega was not in the vicinity of Oumuamua's trajectory around 300,000 years ago, suggesting that Oumuamua has been voyaging through the cosmos for an incredibly long time, reaching velocities of about 59,000 miles per hour. Researchers propose that entities resembling Oumuamua might grace our inner solar system approximately once every year. Yet their faintness and elusive nature mean that spotting them has been challenging until recently. Advances in astronomical technology, such as the Pan-STARRS 1 telescope, are enhancing our ability to detect these enigmatic guests from distant star systems. Paul Chodas of NASA regards Oumuamua with particular interest, as it represents the first identified object from another star system observed in our solar vicinity. As Oumuamua continues its journey beyond the Kuiper Belt, a region filled with icy celestial bodies lying beyond Neptune, it becomes increasingly difficult to observe with our current telescopic technology. This distant voyage leaves us pondering numerous questions. Will Oumuamua ever return? Is it a probe sent by extraterrestrial beings? While these questions remain open, the knowledge gained from Oumuamua's passage has significantly broadened our understanding and fueled our curiosity about the cosmic activities occurring between the stars. To encapsulate, the encounter with Oumuamua was a monumental event because it marked the arrival of a visitor from a distant part of our galaxy. It stands out not only due to its distinctive shape and the path it has traveled, but also because of its velocity. Each observation of Oumuamua enhances our comprehension of the cosmos, urging us to continue our gaze towards the heavens, filled with wonder at the vast mysteries of space. The intrigue surrounding Oumuamua, the inaugural interstellar object seen traversing our solar system, remains a source of fascination for both the scientific community and the public. Research suggests that Oumuamua could have embarked on a journey covering at least 16,000 light-years from its origin. Despite various hypotheses, the precise origins of this enigmatic traveler continue to elude us, adding to the allure and mystery of our cosmic quest for understanding. A well-known idea put forward by researchers Bialy and Loeb discusses the possibility that Oumuamua might be a spacecraft from another world. They suggest it could either be a random piece of cosmic junk or an intelligently designed probe sent to look around our solar system. This suggestion is made more intriguing because of how Oumuamua moves faster than expected and doesn't follow the path we usually see with comets, hinting it might not be a natural space object, but something made by advanced technology. Going deeper into this natural explanation, recent research supports the idea that Oumuamua is indeed a fragment of nitrogen ice that came from a planet very much like Pluto, only located in another star system. This view is based on the observation that Oumuamua sped up near the Sun in a way that could be due to nitrogen turning from solid to gas, a process similar to what we see with comets close to our Sun. This theory is consistent with what scientists have noted about Oumuamua's appearance and behavior. Its unusual shape, initially thought to be long and narrow like a cigar, but now considered to be flatter, and its strange, tumbling motion as it traveled through our solar system, along with its color and the fact that it didn't have a visible tail like comets usually do. This next chapter takes us into the unknown, pondering the exciting discoveries Oumuamua's visit could lead to in our study of the stars, the unseen paths of an interstellar intruder. These explorations and discussions about Oumuamua's true nature and where it came from highlight the challenges and excitements of studying objects that come from beyond our solar system. They underline the need for ongoing monitoring and research to really get to grips with the wide array of celestial bodies that exist out there in the vastness of space. With the anticipation of new tools and telescopes, like the Vera Rubin Observatory, scientists are hopeful about uncovering more interstellar travelers, which could open up even more windows into understanding the universe. Oumuamua itself has stirred up a lot of interest among astronomers for not behaving like the asteroids and comets we're more familiar with. Most notably, it doesn't shine brightly in the sky, nor does it have a tail made of gas and dust, leading to a lot of head-scratching among experts. To shed some light on this anomaly, researchers Jackson and Desch proposed that if Oumuamua were made of nitrogen ice, it would have to be quite small to appear as dim as it does, with dimensions that make it about the size of a modestly sized building. An equally intriguing hypothesis comes from researchers Seligman and Bergner, who suggest that Oumuamua might have been affected by cosmic rays, high-energy particles from space. These rays could have hit Oumuamua and split the water on its surface into hydrogen gas, which then got trapped in a special form of ice. When Oumuamua got close to the Sun, this ice didn't melt outright. Instead, it underwent a transformation that allowed the trapped hydrogen to escape slowly. This slow release of gas could be what propelled Oumuamua through space at its observed speed and trajectory, without producing the visible tail that's typically associated with comets and asteroids heating up near the Sun. How do researchers figure out the size of distant objects like Oumuamua without being able to measure them directly? They look at how bright these objects appear from Earth, combining this information with what they know about the typical reflectiveness of objects in space. Unlike comets, which usually have a visible tail of gas or dust, Oumuamua didn't have one. This led some scientists, including Loeb and Bialy, to doubt that it was a comet. They noticed something else unusual. Oumuamua was moving faster than what could be explained by gravity alone. They speculated that sunlight might be propelling it forward. This idea may seem like it belongs in a science fiction story, but it's based on real technology. On Earth, scientists have experimented with spacecraft that move by catching sunlight on large, thin sheets called light sails. These sails don't need fuel. They move thanks to the gentle push of sunlight. This kind of technology has been tested close to Earth and has been successful. Therefore, Loeb and Bialy speculated that Oumuamua could be an alien-made light sail, extremely thin and propelled by sunlight. Considering what actions to take if Oumuamua, or something similar, returns opens up a realm of intriguing questions and possibilities. To catch such a fast-moving object, humanity would need to harness the mysterious forces of the universe, like dark energy. This is a daunting task. Some have suggested sending a spacecraft to intercept it and gather more information, which would mark a significant advancement in space exploration, necessitating new technologies and innovative thinking. Oumuamua is a mysterious cosmic visitor that has sparked a lot of curiosity. Its strange features and behavior have led to a range of theories about what it is, from a simple piece of ice with hidden gases to a potential alien spacecraft using sunlight for propulsion. Oumuamua has reminded us of the vast unknowns in space and the exciting potential for future discoveries. To travel beyond Saturn's orbit in just 2 years would require a spacecraft with capabilities far beyond what we have today. Current propulsion methods like chemical rockets or ion drives can't achieve the necessary speed for such a trip. For comparison, the Voyager probes, the fastest and farthest human-made objects, took more than 3 years to reach Saturn, using propulsion technology that was advanced for its time, but would be inadequate for a 2-year journey to the outer solar system. Imagine a spacecraft designed not only to escape Earth's gravity, but also to travel through space at speeds never before achieved. This would require breakthroughs in propulsion technology and a new approach to space travel. Perhaps astronauts would board this spacecraft in orbit, having been launched there by a conventional rocket. Or maybe we would see spacecraft assembled and launched directly from space, avoiding the energy-intensive process of escaping Earth's gravity. Solar sails and wormholes represent 2 vastly different approaches to how such a spacecraft could travel. Solar sails, which use the momentum of light from the sun or lasers to move, are based on real physics and engineering, though they're not yet capable of the speeds needed for a 2-year trip to Saturn. Wormholes, on the other hand, are purely theoretical and face significant challenges, including their propensity to collapse, their speculative nature, and the unknowns of how to create one. For us to make a journey to Saturn that would only take 2 years, we'd need a spacecraft that's straight out of science fiction. It would have to use ideas like warp drives or some other form of advanced space travel propulsion, combined with the clever use of resources found in space itself. This kind of project pushes what we know about physics and engineering to its limits. It's not just about coming up with new technology. It's about everyone agreeing that it's worth the effort to push into these new territories of space travel. What happens if we really aren't alone in the universe? Think we can handle it? Smash that like button, hit subscribe, and spill your thoughts below.